Hi, my name is Charlie. You can also call me the Guitar Boy. Today we are going to be doing chemistry, and we are going to be talking about the topic atomic structure 2. In our last class we did atomic structure 1, and we talked about particles of we talked about particles of an atom, and we said an atom is made up of basically three particles, which is electron, proton, and neutron. We talked about their charges, we talked about their relative masses, and we talked about their position in an atom. We're going to be discussing how the particles of an atom are arranged inside an atom, how they tend to behave inside an atom. We'll discuss also some properties of electrons. So today that will be the what we are going to be doing in today's video. Now, who discovered electron? This could be an examination question. You might be asked in an examination, which of these discovered an electron? Now, the person that discovered electron is J.J. Thomson. He discovered electron in 1897. In the year 1897, J.J. Thomson discovered electron. How did he discover it? Before I go into how he discovered electron, we have basically three states of matter. We have solid state, we have liquid, and we have gaseous state. Now, these three states of matter, and how do they conduct electricity? How do these three states of matter conduct electricity? Let's talk about the solid first. At your home, you see how electrical wire, solid, right, conduct electricity. So some solids conduct electricity, while some other solids do not conduct electricity. Those solids that conduct electricity are called good conductor. Also, some liquid conduct electricity when they have in them ionic compound dissolved in them in solution form. They conduct electricity. So you see, solid conduct electricity, liquid also conduct electricity. Not all anyways. Some liquid that contains ionic compound in them, they conduct electricity. What about gases? Do gases conduct electricity? If you ask me, I will say yes, and I will also say no. Look at the reason. There is a condition in which gases conduct electricity. There is a condition in which there are conditions that needed to be met before gases can conduct electricity. So if it meets that conditions, it will conduct electricity. What is the condition? At a very high potential difference or voltage. If I say potential difference, I'm also talking about voltage. Most of us would have been using that word voltage. Voltage is the same thing we are talking about. We have high voltage in our house. Is the same thing we are talking about here. So high voltage of about 1,000 volts. So at a high voltage of about 1,000 volts and above, 1,000 volts or above. So when you have high potential difference like this, and at low pressure of 0.0001 atmospheric pressure, at this particular high potential difference and low pressure, gases will conduct electricity. What does that tell you? If you have a low potential difference and a very high pressure, gases will not conduct electricity. So that is why I told you yes or no, because normally at high, if you don't meet these conditions of high potential difference, or like I told you, if I say potential difference and voltage, I'm talking about the same thing. So, and low pressure, if you don't meet the condition, gases will not conduct electricity. Now with this, J.J. Thomson in 1897 was able to prove the existence of electrons by using a discharge tube. This is a discharge tube or a glass tube. If you like, you can call it a glass tube. In this glass tube, you have two electrodes. One here, one here. This one, let's call this electrode cathode. the negative terminal. Let's call this electrode, anode, the positive terminal. So these are wire. These are wire. So imagine this wire conduct the electricity to this point, conduct this one, takes it away. Imagine it conduct, what will not conduct it from here to here? So that is the gas will not be, it is gas that will be inside here. So the gases will conduct the electricity from here to here, and just like that. So that is what we are talking about here when we say gas can conduct. Gases can also conduct electricity. They can allow electrons to flow through them, but you must meet a particular condition. So now, when J.J. Thomson did his experiment here, J.J. Thomson first used a potential difference of 5,000 volts. When he used a potential difference of 5,000 volts, let's say these are the gases, the gaseous atoms we have here. So these are the gaseous atoms we have here. So when it passed a high potential difference through it, there was electron emission of a streams of electron from the cathode to the anode. There were streams of electron that's a number of electron that was moving in a straight line from this side like this, hitting the gases like this to the anode, from the cathode to the anode. Hence the term cathode ray. So these ones are cathode ray. So this was cathode ray, a ray that moved from this side to this side. Now at a low pressure of 0.0001 atmospheric pressure. That was the pressure J.J. Thomson used in carrying out this particular experiment. It was rays of light from the cathode to the anode in a straight line, moving from this side to this side. So at high potential difference, maybe from a power source, from here, pass it through the gas and conduct electricity, just like that. When J.J. Thomson used this particular follow this condition, use 5,000 volts and 0.001 atmospheric pressure, he saw a glow, like a light inside the bulb. So when J.J. Thomson now increased the potential difference to what, 15,000, he saw a green glow in the tube. He saw a green glow, a green light in the tube. So that was how J.J. Thomson now further went, what are these streams of particles moving from the cathode to the anode? They had to carry out further experiment to test whether the particles here are positively charged or negatively charged. Either use I guess either use a magnetic field or electric field. Imagine I have a magnet, I position the north pole of the magnet close to this tube, and the north pole is positively charged. So if this stream that is moving in a straight line, if I carry it close to it, if it is a positive charge here, you see it will repel, it will push it away, because like charges repel, unlike charges attract. So if it is opposite charge, which is negatively charged, it will bend towards it like this. It will bend towards it. That was how J.J. Thomson, when he carried the north pole close to it, the ray bent towards it like this, and it was attracted by the magnet. And now, so wow, this stream of particles moving from the cathode to the anode are negatively charged. This invariably, he now concluded that this invariably would be the electron our scientists did talk about that is responsible for electricity. So that was how J.J. Thomson discovered electron. He went further to carry out some experiments on this, to study about this cathode ray. The more he now had some properties that he outlined about this cathode ray. Let us now list some of the properties he listed about this cathode ray. So after the whole experiment by J.J. Thomson, he was able to outline some characteristics of this stream of electron, which is called cathode ray. It was cathode ray, which is called cathode ray. He was able to outline some properties of this stream. He said, number one, that they are that they move in a straight line. Number two, they move in a straight line and can cause and can cast shadows on opaque objects. Number two, they are negatively charged particles, and three, they can cause mechanical motion. And number four, they are identical even in charge per mass ratio irrespective of the residual gas in the tube. So these are the properties that J.J. Thomson, after further experiment, now outlined about this cathode ray, this electron. He said they move in a straight line. This ray move in a straight line and can cast shadow on opaque objects, and they are negatively charged particles. You see, when we use magnet then during the experiment, it showed that they are negatively charged particles, that they can cause mechanical motion. That is, if you place in their path a light wheel, they can cause the wheel to rotate. So they can cause mechanical motion. They are identical. Electron is electron. So, and as a result, they are identical even in the charge per mass ratio. The charge per mass ratio, they are identical irrespective of the residual gases. Maybe the residual gases means the gas you have in the tube. So which type? Is it hydrogen gas? Is it helium gas? It does not matter. What matters is that they are charged to the charge to mass ratio of any of these gases are constant rather. So he went further in his experiment to calculate the charge to mass ratio of an electron, also known as specific charge of an electron. It went further to calculate the charge to mass ratio, also known as specific charge of an electron to be 1.76 times 10 raised to power minus 11 coulomb per kilogram. And another great scientist, R.A. Millikan, in his oil drop experiment, was able to calculate the charge of electron to be equal to minus 1.6 times 10 raised to power minus 19 coulomb. So he was able to calculate the charge of an electron to minus 1 0.6 times 10 raised to power minus 19 coulomb. If you check here, you see this negative sign here. This negative sign shows that indicate that electrons are negatively charged. Now, from these two combinations, if you combine these two work together as a mathematician, you should be able to calculate the mass of an atom. And the mass of an atom was calculated. Now, this is a simple mathematics to calculate it. I will not do it on this video. So the mass of an electron was calculated to be mass of an electron was calculated to be the mass of an electron was calculated to be 9.1 times 10 raised to power minus 31 kilogram. So as small as this, very, very small. So you can neglect it. This is the mass of an electron, which is what? Very much negligible. So we are going to end this video here. I would have loved to finish every work of J.J. Thomson here. In the next video, we'll just talk about that, complete the remaining part of the work of J.J. Thomson, because this particular video is becoming too long. Now I need to break it here. So we'll talk about them. From there, talk about the little things about it, then talk about what is model of an atom, what it now says an atom is. When I mean what it now says an atom is, so we are going to talk about that in our next video. So take note, J.J. Thomson, they can ask you in exam, was the person that discovered an electron. And they can also ask you in exam, how can gases, which condition can gases conduct electricity at high potential difference and low pressure? So you must put those things in your head. And they can also ask you to outline the properties of cathode ray. So you should put those things in your head, as they are very, very necessary for you to know as per the exams you are preparing for. So if you are here in Edo State, Benin City, we are here in Benin City, Edo State, Sapele Road Bypass. We are close to Belisima Junction. If you want physical classes, you can contact us via our WhatsApp number, contact on this page, and reach us. So we'll be happy to have you with us. Thank you for watching, and make sure you like and share, comment. You can ask any question. I'll be glad to answer your question. Bye. We'll meet in the next video. God bless you.